So this is Investigation 7B or Lab 7B. You should have this handout, and like most handouts, you should probably read it. As well as reading this, realize that the lab itself comes from page 227 or 226 and 7 in your textbook. This is one of the few formal lab write-ups you actually do in Science 9, and by a formal lab write-up, you should probably see the skills handbook in your textbook, page 556, 557. The idea here is to start with the title, include the page number, date, the names of your people working in your group. Like all good scientific investigations, you really should start with a question. What are you really trying to determine in this lab? Make a prediction. I don't see the point of you copying out all the materials, so just something to the effect, see page 226, 227 of the textbook would be fine. A data table, what you're looking at here is the progress of a chemical reaction, so things in that table like prior to, what did the reactants look like, the things that you started with, and then as the reaction is taking place, what do you see, and then during the reaction, after it, and maybe even after filtering. I'll say more about that in a second. At the end, you basically analyze your results, answer the questions, and you're good to go. Make sure you clean up all the materials, dispose of the copper 2 chloride. I have a container out there. We don't want to kill any fish, and you're actually going to make copper metal from a ionic solution of copper 2 chloride here, so you do have the option of drying the unrefined copper metal on a paper towel, and you could actually heat it and turn it into the metallic bonds that you recognize in your friendly neighborhood pennies, if you've seen any of those lately. Yeah. This, of course, is what the actual lab looks like in your textbook, page 226. Make sure when you're working with your group, you guys take time to read the directions first. There's not only important information you need there to figure out the purpose of the experiment and answer the questions that follow, but there's also a lot of safety considerations as well. So I'm just going to focus on a couple of them here, just in case you don't read this. What you're dealing with here are the differences between ions and atoms, and they're different. You can have an ion of aluminum which may be colorless, and yet you could have aluminum metal. It's on the periodic table, which is actually a metal. You could have chlorine, again colorless, but when it's combined with something else, have totally different properties. You're going to be using copper ions, which are, depending on whether they're hydrated or not hydrated, either brown or blue, and again the color is going to depend on a whole lot of factors. So I'm going to read this to you. Ionic compounds form when a metal reacts with a nonmetal. The reaction creates oppositely charged ions that are chemically different from the original atoms. Some elements are very reactive and form ionic compounds with a variety of elements. Chlorine is an example of a very reactive element. As an element, atom, it is a yellowish-green gas that is extremely corrosive, deadly. It was used as a weapon by both sides in the First World War, causing many deaths and casualties. Yet the chloride ion is an essential part of nutrition. You put it on your tomatoes, you add it to your food. It is found as a safe and stable part of many important compounds. Sodium chloride is an essential part of your diet, even though it is made from the ions of two very reactive chemicals. So I've highlighted the next sentence or two because this is really what this lab is all about. The properties of an element's atoms are quite different from the properties of an element's ions. In this investigation, you will compare the properties of an atom and its ions. So copper 2 chloride is corrosive and poisonous. Take care to avoid drips and wipe up all spills promptly. If any solution splashes on skin or in eyes, flush immediately with plenty of cold water and let me know. So I suggest when you follow through with this experiment, you just keep on reading through it. The question, a prediction, the experimental design. Like I said, you don't need to copy out the materials, but the procedure is important. So, when you are ready to do Lab 7B, see me for a beaker of copper 2 chloride. Notice that the copper 2 chloride that you are dealing with here is this guy over here, the brown one, the copper chloride anhydrous. Anhydrous simply means it's lacking water. If you add water to copper chloride, it's going to turn this blue-green color. That is basically the start of the solution you're going to make. Following the procedure in the lab, you actually add water to the copper chloride and you make a copper chloride solution. We say it's an aqueous solution. At that point, you're going to add aluminum metal. You know what's a metal? Shiny, malleable, bendable, all those properties of metallic aluminum. Once you add the metallic aluminum to it, you are going to get a reaction. I'm actually going to attempt to show you the reaction here, because the reaction takes place as an ionic reaction. In Science 9, you don't really get into the types of reactions, but Science 10, this is called a single replacement reaction. Single replacement. And what is being replaced here are the metals. There's an activity series in metals where metals higher up in the activity series will replace metals lower. And it just so happens that aluminum is more active than copper and will replace copper if the two of them are present. So the reaction that you're actually doing here is copper chloride, CuCl2, copper 2 chloride, and then you're adding aluminum metal, and we just draw an arrow, which means gives copper. And now this is metallic copper. It won't look like the metallic copper of a penny because it's unrefined, but this is in fact atomic copper. Plus you have something called aluminum chloride, AlCl3. And again, these lovely little numbers here, subscripts, just tell you how many atoms of the atom there are. Okay, that really looks bad. That's Cl3. Let's do that again. AlCl3. And just so you realize what's going down here, you are, when we said a single replacement reaction, this copper here is being replaced by aluminum to form aluminum chloride, and that is going to leave the copper atoms here, right? So the interesting thing to me, though, is that the copper itself starts off as being blue. So this would be blue. And you're adding it to shiny metallic aluminum foil, and those properties of aluminum are going to disappear because you end up with a saltier aluminum chloride, which is colorless. You won't even see it in the solution. And again, now you're going to end up with copper, which we'll say is bronze or brown. And yeah, so what we're noticing here is that the ions in this solution, and the ion actually is a Cu2 plus ion, and this ion, aluminum 3 plus, is going to replace copper 2 plus. So you take your solution of copper 2 chloride with now the bits of aluminum floating around in it, and copper metal is going to form on that aluminum, and pour it into the funnel. So yeah, the funnel itself you should be able to find in the lab, and it's just a matter of putting a piece of filter paper in it. If you don't remember how to fold the filter paper, there you go, and you filter the solution. What you're going to get is that filtrate, which is going to contain the only thing that should be in the filtrate is the aluminum chloride, the AlCl3. and it'll be kind of a cloudy color, but it certainly won't have the properties of aluminum that you had in the first place, because aluminum is a shiny metal. Aluminum chloride. For some reason or other, I want to forget that chlorine is Cl, not C, so shame on me. You will then do something really fancy and make sure that you have been keeping a data table as you go along. Maybe just prior to, these are the kind of things you're going to write down. The fact that it is aluminum, how do you spell aluminum? Aluminum is shiny. That's a kind of an obvious one. Copper 2 chloride, you could give the color of that. The solution of CuCl2 is blue. Then beginning in the reaction itself, solution blue, contains foil. And this is where during the reaction you should notice that energy is given off, heat is produced, evidence of a chemical reaction, heat released, bubbles. Actually can get rather hot. And what you are going to notice is that red-brown copper metal or atomic copper forms in that solution. The solution after, if you keep adding enough aluminum, you will eventually get a solution that is colorless, even though it still contains aluminum chloride. And after filtering, just basically give us the color of the copper in the filter paper. The only thing left then in that lab is to make sure you cleaned up after yourself and then move directly on to the analysis questions, evaluation, and synthesis. You know what? Some of these may cause you to shake your head a few times. If you're stuck on a few of them, don't hesitate to ask for a bit of help, and we'll give you a hand.